What's up everyone? In this video we're going to be talking about finding the volume of prisms and of cylinders. So recall that volume is kind of like the 3D version of area. Area was the space occupied within the boundary of a 2D shape, and volume is the space occupied within the boundary of a 3D shape. Now, the same way for area we had units squared because it was 2 dimensions, right? We had like length times width. But for volume, there are 3 dimensions now. So we have length, width, and then we are adding this like 3rd dimension of height back here. And since there are 3 dimensions, our units are cubed. Now, recall that a prism is a shape that can have a variety of different shapes as their bases, but all other faces are rectangles, and the amount of rectangles depends on the number of sides in the base of the shape. So, for example, if we have like a pentagonal prism, we know that our first word tells us that the base is a pentagon, and then since it's a prism, all other sides are rectangles. And since the base is a pentagon, I know there are 5 other rectangles in there, right? So the same thing holds. Just be careful with triangular prism. Even though it looks like a triangle is sitting on that rectangular face, the first word of the shape always tells us what the base actually is. Now for volume of prisms, this is for any prism. So if we go on this last slide here, we can see there are so many different types of prisms. Now this is the general formula, and you guys are also given this on your reference sheet here. You can see it says general prisms, and that formula for volume is V equals capital B, which is the area of your base, and H is the height of your 3D figure. So your base, again, can have a bunch of different shapes, like a square or a triangle or a rectangle or a hexagon or a trapezoid. So depending on what the shape of the base is, that original area formula here for capital B is going to vary, but then the height of your 3D figure should remain the same. So let's get right into an example here. So let's find the volume of this triangular prism. Now, the first thing we need to ask ourselves is, what is the shape of our base? Now, if the name is given to you, the first word tells you what the shape is. So this is the base is a triangle. And a lot of people get this confused because they're like, well, miss, it looks like it's laying on that rectangular base at the bottom. Nope, it's a triangle. Don't get tripped up on that. Now, to find the area of our triangular base, you're given this formula on your reference sheet. It's 1/2 BH, or another way to think of it is BH over 2, right? Now, if you look at your triangle, and we just highlight our triangle here, the base of our triangle is 8, so A equals 8 times. The height of our triangle is 6. We divide that by 2, and when we put that in our calculator, we get 24 feet squared. Now, a lot of people get this tripped up because volume is equal to capital B, which is the area of our base that we just found, times our height. So we can go ahead and actually start substituting. So V equals our capital B, our area of our base was 24 times. Now we need the height of our prism. Now, some people will say, hey, 6 is the height of our prism. No, 6 is the height of your triangle here. The height of the prism is this extra dimension down here. It's kind of like what's making it 3D. So the height of your prism is not 6. The height of your prism is here. We're stacking these triangles all on top and on top and on top of each other, and this value here, this is the height of your prism. So be extra careful. Do not mix up the height of your triangle with the height of your prism. The height of your prism is 9. So when we actually do this calculation, we get that the volume of our triangular prism here is 216, and our units are cubed, so feet cubed, and that is our volume there. So again, it all started out with figuring out the area of our base first, and then we multiplied by our height of the prism. Now, in another example, we have a rectangular prism. Now, again, the shape of our base here is going to be a rectangle. Now, to find the area of a rectangle, right, in our rectangle, sometimes it helps to really highlight your base so that you don't get things confused. But the area for a rectangle is just length times width. So this is an interesting one because we know that our volume is capital B times H, but now we know that for a rectangular prism, that instead of capital, we know that that's just going to be length times width. So if we rewrite the volume formula for a rectangular prism, we just need to do length times width times height. So if you want to, you can go this route and find the area of the base first. And it would be pretty much the same thing. You'd get area equals 5 times 4. So we would get 20 centimeters squared for our area, right? And then we'd substitute that in down here. So we would get V equals 20 times the height of our prism. Now the height of our prism is this value here. That's 11. So when we do that, we get that our volume is 220 centimeters cubed. Now another way you could have done it, when you get used to this, you know volume is just length times width times height. So instead of separating the base, you could have just done 5 times 4 times 11. And for any rectangular prism, you're allowed to do this. And if you did this, you'd get the same volume as 220 centimeters cubed. So this method will connect to all of the other volume concepts, but if you can remember that this is the volume of a rectangular prism, then you can go for it. Now let's get into a third example where we're talking about cylinders. So for cylinders, the shape of our base is a circle. Now the same type of concept is going to apply for a cylinder. We got to find the area of our base, and then we are stacking it up or multiplying it by our height to figure out the entire volume. Now the interesting thing about a cylinder is that they give it to you on your reference sheet. Like they separate it and say, hey, here is the volume for a cylinder that's pi r squared times the height, right? So for that, you just go pi r squared h. We are already given our radius is 6, and we know the height of our cylinder is 11. So we can go ahead and just substitute. So pi times 6 squared times 11. Now be careful, make sure you're only squaring the 6 here. That's going to give you pi times 36 times 11. And then if you do that in your calculator, we get that the volume equals 396 pi. And I'm going to leave it, since it doesn't specify, I'm going to leave it in terms of pi, and we have meters cubed. Now this relates, right? If we did V equals capital BH, remember the area of or the shape of our base is a circle. So still we would take this base and we would put pi r squared, and then we multiply by the height. So that's where it comes from. It still comes from capital BH, but it is nicely given to you on the reference sheet. Now, a word problem involving volume, we might have to use the volume of a figure to find out some other dimensions. So we have a fish tank with a rectangular base, has a volume of 3,360 cubic inches. The length and width, so I'm going to start making my list. So the volume is 3,360, the length is 14, and the width is 12, and it wants us to find the height. Now they're giving us the volume here, so we know we have a rectangular prism. This was the one where we can do L times W times H. Now let's go ahead and substitute. So 3,360 equals our length, which is 14, times our width, which is 12, and we're looking for our height. So now we just got to do some algebra. So we get 3,360, and if we multiply 14 times 12, we're going to get 168 times H. We divide by 168 on both sides, and we get that 20 is equal to our height. So 20 inches, if we included units, would be our height. Okay, now again with this, you want to make sure you make your list of variables, write out your entire formula, substitute, and then solve. All right, last but not least, we have some questions involving some real-life context. So these can be wordy, so you want to make sure you annotate, you underline, and then you make lists of information so you know what's going on. As shown in the accompanying diagram, the length, width, and height are 24, 16, and 18. So I'm going to go ahead, just so I don't get lost in the sauce. We have length is 24, the width is 16, and the height is 18. Now Richard is filling his fish tank with water from a hose at the rate of 500 cubic inches per minute. So we're going 500 inches per minute. Now we want to know how long it'll take to fill the tank to a depth of 15 inches. So what we want to notice here is that the entire height, the entire depth of the tank was 18 inches, but we're not utilizing that entire 18 inches. We want to only fill the tank to 15 inches. So instead of using 18 for our height, we're going to just be using 15. So let's just figure out how much water can this fish tank actually hold. And then once we know how much water it can hold, we can figure out, hey, how many minutes is it going to take to fill it, right? So our volume is going to tell us how much it holds. And if we did our length times width times our height, we get 24 times 16. And again, we're using 15 because we're only filling the tank to that depth. We're not filling it the full 18 inches. So if we put that into our calculator, we get that the volume is 5,760 inches cubed. Now what that means is in total, this tank holds 5,760 cubic inches of water. Now, if we're doing it at 500 cubic inches per minute, what we need to do is take that entire volume, 5,760. If we divide it by 500, it's going to tell us how many minutes it's going to take. And if we do that, we get 57.6 minutes. And always go back to your question, what do we want to round to? So let's do the nearest minute. So we're going to have 58 minutes. So it would take 58 minutes to fill this tank up to a depth of 15 inches.